All right, today what we are going to do is we are going to look at how do we solve systems with word problems. Now, the math that we're actually going to be doing is no different than the math we've been doing for this whole unit. The only thing different now is we are actually going to shift to just giving you a system to giving you it in a word problem. Now, let's talk and go through the steps of what you're going to want to do. Step number one, what you're going to want to do is you're going to want to label your X and your Y. So in other words, what does the X stand for? What does the Y stand for? Typically, you can read the last sentence of a story problem, and it is what you are finding. So if it says, how many adult tickets and how many children tickets are sold, what is the cost of a pizza and a like pop or something, So if you read that last sentence, it walks you through, this is what X stands for, this is what Y, and you can decide which one's which. Now, once you do that, you're going to write two equations based on the word problems. Remember, you need two of them. What you're going to try and kind of look for are things like day one, day two, Johnny's and Samantha's, sales, something like that. Like, it's going to give you a sentence, and in that sentence, you should be able to find an equation based off of that. Some things to think about, day one, day two, like profit versus sales, total sold and the money made, different things of that sort. Now, when you're doing that, it is also probably a good idea to cross off information that is not needed and highlight or underline the important information in each sentence. Once you do that, you are simply going to solve the system with the three methods we've learned up to this point. Now, I will tell you, graphing should be your last resort. Use substitution or elimination and use the one that the equation is set up to be with, like right away. And then the last thing is make sure to answer the question. So when you look at the question, read through it again and ask yourself, did I answer the question? Does my answer make sense? Does it sound like that could be the answer? Those types of things. So often students will just write something down and that answer is way off, and you can tell it if you just take a second and reread the problem. All right, so let's give this a shot. So example one, Kim's school is selling tickets to the annual dance competition. On the first day of ticket sales, the school sold 4 adult tickets and 10 child tickets for a total of $180. The school took in $66 on the second day by selling 1 adult ticket and 4 children's tickets. What is the price each of 1 adult ticket and 1 child ticket? So the first thing we need to decide is, what are we looking for? So what I'm going to do is I'm going to let the X stand for the adult ticket. I'm going to let the Y stand for the child ticket. Now we need to come up with our equations. So what I'm going to do is I'm going to go through and I'm going to highlight. So on the first equation, it says the day of ticket sales, the first day, we have 4 adult tickets, we have 10 child, and we make 180. So over here, I'm going to write that. It's going to go 4 adult tickets. Remember, X stands for the adult, plus 10 child tickets. Y stands for child. And if I multiply and add that together, it should equal $180. Then I look for the second one. It says the school took in $66 on the second day with 1 adult and 4 child. So 1 adult, so 1X plus 4Y, and that equals $66. Now, when I look at this system, the thing I'm thinking of is it's set up right away for elimination. So now what I am going to do is I'm going to take this bottom equation and I'm simply going to multiply it by -4. So what that now gives me is 4X plus 10Y equals 180. And then that gives me -4X minus 16Y, and that equals -264. I now add going down, so that cancels that. That leaves me a -6Y, and that equals a -84. I'm going to divide by the -6, so Y is equal to 14. At this, I take that, plug it back in, And now I have x plus 4 times 14, and that equals 66. So x plus 56 equals 66, minus your 56 from both sides, and that gives you x is equal to 10. Remember, x was the adult tickets, so the cost would be $10. The cost for the children's ticket is $14. And that's how we go about doing that. Okay, let's take a look at another one here. So the second one, we're going to do some sales of things. Okay, the first thing I'm going to tell you right away, there is a typo. This should say cost of daylilies and cost of geraniums. I apologize for that. So when we go through, it says Elisa and Matthew each improved their yards by planting daylilies and geraniums. They bought their supplies from the same store. Elisa spent $265 on 12 daylilies and 11 geraniums. Matthew spent $123 on 2 daylilies and 9 geraniums. What is the cost of 1 daylily and the cost of 1 geranium? So as we look through, I really don't need all of these first 2 sentences. That's really just extra information at this point. So when I look, my X is going to be daylilies, and my Y is going to be geraniums. Okay, now we're going to make an equation for Elisa and an equation for Matthew. Elisa spent $265. She got 12 daylilies and 11 geraniums. Matthew spent $123, got 2 daylilies, 9 geraniums. So let's start with Elisa. 12 daylilies. Remember, X is the number of daylilies, the cost of each daylily. So 12X plus 11Y for geraniums, and that equals 265. The second equation, the one for Matthew, we have 2 daylilies plus 9 geraniums, and that equals 123. As we look at this problem is once again set up for an elimination process. So I'm going to take the bottom equation and I'm going to multiply it by a -6. So that gives me 12x plus 11y equals 265. I'm going to get negative 12x minus 54y, and that equals negative 738. So I'm going to add down those, and that's going to get me negative 43y, and that equals negative 473. I'm going to divide by my negative 43, and that leaves me y equals 11. So now I take that, plug it back in. So now I have 2x plus 9 times 11 equals 123. So 2x plus 99 equals 123. So 2x equals 24. Divide that by 2, and x would equal 12. So the cost of my daylilies is $12. The cost of the geraniums is $11. Okay, so let's try this third one. Jonathan is looking at joining a movie club. Magical Movie Club offers 2 options. Option A is a $20 flat fee and $5 per movie. Option B is a $30 flat fee and $3 per movie. How many movies does Jonathan have to attend to make the options equal? What will be the cost when the options are equal? So the first thing we look at is, what are we looking for? Well, the first one is the number of movies. The second is we're looking at the cost. Okay, so let's go through the options here. Option A, we get the cost is going to equal $20 flat fee. So no matter what I do, I'm going to pay $20 plus $5 per movie. So per movie means we're going to multiply that. And then option B, we have $30 flat rate plus $3 per movie. Now, if you look at this problem is set up for substitution. So we're going to take this first equation, plug it in for y. So we get 20 plus 5x equals 30 plus 3x. I now get my x's to the same side, so I minus 3x from both. That gets me 2x over here. That cancels. So I have 20 plus 2x, and that equals 30. Now at this point, I'm going to minus 20 from both. So I get 2x equals 10. Divide by 2, x equals 5. Now I take that, plug it back in, and that would give me y equals 20 plus 5 times 5. And y equals 20 plus 25, which is going to equal 45. So the total cost when those are equal will be $45, and that would be looking at 5 different movies. And that's how we set up and solve word problems that involve systems.